Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this Techstrong Learning Experience brought to you by Bitrise. My name is Cody, and I'm the host of Techstrong Learning, and we have an exciting program ahead. Before we begin, I do have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, perhaps you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. Now, you'll notice on the right side of your screen, there are a couple of ways that you can engage with us today. First of which is the chat tab. So I'd like you to start using that chat tab with us right now by letting us know from where you are joining us. Now, if you have any questions for Nick, we are going to be holding questions until the end. So go ahead and send them to that Q&A panel, and we'll be sure to address them at that point. We have a couple of polls that will be opening throughout today's program. So as those pop up, please let us know your feedback as we really want to kind of gauge you on some of these topics. If you jump to the handouts, you'll see there are a plethora of resources available for you. So feel free to grab those at your own leisure. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around to see if you're one of our lucky winners today. So our program today is titled Mobile DevOps, The Need for Speed. And I'm joined today by Nick Sanjeans, Senior Solutions Engineer at Bitrise. Nick, I apologize if I mispronounced your last name, but thank you so much for joining me today. I'd really like to turn the floor over to you.
Awesome. Thanks, everybody. And I'm Nick. I'll be taking us through here, but as Cody mentioned, Senior Engineer, Solutions Engineer with Bitrise. So as we jump right in, I'll walk us through just a quick agenda. Right, we'll go through a little bit more about me, expanding upon a little of the mobile DevOps pillars, and then where we'll be focusing in today, which is the need for speed. Walking you through kind of how to get started, how to take that next step and really level up as a lot of top-tier mobile organizations are doing. And then we'll have time at the end to wrap up for any questions you may have. And let's get into it. So, as Cody mentioned, I am a solutions engineer with Bitrise. However, prior to that, I spent about 12 years in mobile development. So I started more in the back end, moved into mobile, and so have a lot of expertise in building Android and iOS apps, as well as all the surrounding components, which is really what's making DevOps, to build and deploy those to our customers. In the pre-sales role, I've worked with many companies, large and small, to really help improve their productivity, mainly through DevOps automation. And then a quick intro about Bitrise. If you haven't heard of us, we are a mobile DevOps platform, specifically Android, iOS, cross-platform, macOS, tvOS, right? But mobile first. So everything we're doing is through the eyes of how do we make mobile a first-class citizen? How do we help you optimize for speed, right? And obviously fully managed cloud-based service. Now, as we get into the mobile DevOps pillars, what these are, we expanded upon DevOps pillars as it relates to the industry as a whole and added some components in here as it relates to mobile. So things that are across the board, right? IT ops automation. So being able to offload your management and build infrastructure. We'll talk a little bit about this, but instead of having the Mac Mini or machines in a data center on your desk, how can you offload the management of that so you can spend more time doing the things that you love, and which is building new features, and not the things that are stressful and challenging, which is juggling a bunch of Macs and OS updates. Likewise, workflow management. So enabling to manage the workflows, the steps involved in actually building your app without having to be an expert, right? And so this is where Bitrise comes in. We'll showcase some of that a little bit later. CI and test automation, super important in the life cycle of building and deploying your app. And so how can you do that to get started and then obviously at scale? App release management is something unique to mobile because you have to go through the stores, right? iOS being the App Store, Android being the Play Store. And there's a set of restrictions and complexities around that. So making sure that you have all the tools that you need to efficiently get those apps out to your customers. Obviously, security, very important, right? How do you automate as much of those security checks as possible to decrease the risk to the business when there are identified vulnerabilities? How can we fix those? And then obviously insights as you get into there, optimizing your mobile app size, for example, because you want to make sure that app downloads quick for your end users, as well as other things to optimize your builds, right? So encompassing all these together are the 6 core tenets or value pillars of mobile DevOps. Today, we'll focus mostly on the first 2, IT ops automation and workflow management. However, later, if you have questions, happy to get into some of the others. All right. So as we get into this, I wanted to start with a little story, right? Where we're at today, and this is really a question to everybody. I think there is a poll question out there. Feel free to answer kind of where you're at. So, what CI/CD platform you're using, if any, and then as well as, what are some main challenges that you're having as a result of that? One more that may be a good poll question to ask is, what's your current release frequency? Right. So going through these, helping understand where we're at as an organization is important. However, the reason that we want to automate, the reason we want to make this faster is all about developer productivity, right? So to kick off with a story, as a developer, and I spent a lot of my years as a developer, finding where to make a change usually takes 90% of the actual piece that it needs to fix. So whether it's a bug or adding a new feature, combing through, hundreds of thousands or millions of lines of code and project files to find the exact place I need to make a change or add a feature is time consuming. And then once I make the change, maybe it's, a few lines to maybe a couple hundred lines of code that you're adding, you need to go ahead and run that build and know, did what I just wrote break anything, right? Did what I write actually fix the problem or add the new feature? So I want to know those things as quickly as possible. And the reason that it's important is I like to use this example of placing your keys, right? So if I come home, and this was back in the days of pre-COVID where I went into the office, right? And I come home, drive home, put my keys on the counter, get my gym bag, and leave for the gym. I know exactly where my keys are, no problems, and they don't get lost. Because the time when I put them down to the time I picked them up again was relatively short. Now, in another case, I come home, maybe I hit the bar after work, come home, set my keys down, and maybe my wife moves some mail on top of my keys and things get moved around. I end up, getting a shower, going to bed, sleep through the night, wake up the next morning, late for work, and I don't know where my keys are. And I tear the house apart everywhere that I've seen the keys in the past. They weren't where I thought that I left them, right? This context switch is exactly what developers face. And this is why it takes so much longer once you switch context to actually make a change. Again, because finding where to make the change is the bulk of the work. So if we start with maybe a manual process, I have a manual build process today. That's great, but it leaves a lot to be desired in terms of how fast you get that feedback. And then the next step, let's say we're at the crawl stage where everything is automated, right? But it's really slow. And so that leaves more optimization to happen. And every step we take along this path helps us get that much closer to as fast a build as possible. Usually the industry benchmark is anything under 10 minutes is desirable. If I have a 10-minute build, it's exactly what I want. Quick question. I don't think it's a poll, but feel free to put in there. What is your average build time from a developer when you commit? If you're running an automated, like to see what's going on out there. Okay, so we talked a little bit about why we want to make some improvements, but I'll take a step back just for those of you maybe that haven't been in this automation CI/CD learning for the first time. I'll give just a brief background. Right? What is it? Very briefly, continuous integration and continuous delivery, kind of broken into two parts. The integration is automating the full process of adding new code into the next stage, right? Into like the main or develop branch, right? So this goes through compiling the code and deploying it to an environment. And then the delivery aspect, the continuous delivery, is an extension of that, taking your built application and deploying it to production, which in the mobile realm means the App Store, right? Out to your customers. Now, we talked about why we want to speed up the build. A lot of these relate to automation and why we want to do it. First and foremost, happy customers, right? The faster, fewer bugs that make it into production, the better user experience. And this is especially true for mobile, as every application, whether you have 5 developers in a startup or 5,000 developers in an enterprise, a large enterprise, every app as it relates to your customer is looked at through the same lens. As an example, I would maybe look at a restaurant app with the same eye that I do with Amazon, right? And I expect that the restaurants app has exactly the same features and functionality. So there's parity across the two, right? So the closer I can get to that, making sure my app works is imperative. And that's why we want to automate this build process. Likewise, we mentioned increased developer productivity. So reducing the firefighting and that context switching of a developer having to manually do these tasks, right? Having them spend more time on coding and less time on dealing with build machines, OS updates, fighting the build to make sure, hey, it worked on my machine and it doesn't work in CI, things like that, right? And then lastly, ability to more quickly recover from incidents, right? So it's inevitable, bugs happen. How quickly can we react to finding out of that bug? So the time when I am aware a bug exists to the time it's fixed in our users' hands, lowering that time obviously is much easier with a fully automated process versus manually clicking buttons to get everything out. Right. All right. And then what are the things we need to automate your mobile app? And for mobile, this is a little bit different, right? Specifically iOS, you need Mac hardware to build your apps, right? This is in stark contrast to building web and backend, where maybe you need a Windows box or Linux box, to build iOS apps specifically, you would need Mac hardware, right? This comes with some rack space potentially in a data center or under a desk at a small scale. In addition, you need a consistent environment. I want to make sure that when I run a build, that it passes when it's supposed to pass and it fails when it's supposed to fail, right? And to make sure that that layer is consistent, virtualization is, I put optional here, but in reality, virtualization is what's guaranteeing I have a consistent environment, that there's no stored keys on the bare metal that are conflicting or different versions of a dependency that clash, right? So multiple things that can happen if you're running on bare metal, and virtualizing just adds another layer of overhead to help that consistency. Obviously, we can get into more things like fleet orchestration, managing your elastic environment potentially, creating and distributing the VM images, and then dealing with the life cycle of that hardware. Lastly, being able to load balance the actual builds as they're running, and with an organization, in the maybe 5 to 20 developers, that may be not as big of a spike. But when you get into the hundreds and thousands of developers, orchestrating the build to make sure that everybody doesn't hit commit at the same time and overwhelm the system, leading to just more time, is imperative. Obviously, at scale, this requires a team. In some of the smaller organizations I work with, maybe they are pulling a developer or two off of the project, maybe for an hour a day, maybe a few hours a week, which is biting into their release cadence or the amount of story points they're able to get out. Right, a lot of work, and at Bitrise, we would say building and managing that in-house is a little bit too much work, and that's where we come in. So I have a little demo here that I'll slide over. So to showcase this part first, right? As Bitrise is a mobile specific DevOps platform, we start with the hardware. So this is everything from your Intel hardware to your M1, M1 Max, M2 workloads, right? And what this enables you to do is choose the size machine that works for you. Maybe you're running something small, maybe some tests, and on a third-party provider, and a cheaper, smaller Intel machine works. Or you're running a nice, advanced build system setup, which takes multiple cores and machines, and you need to run that build on like an M1 Max. So you're able to choose what machine makes the most sense for your workload. And then on top of that, Bitrise is handling all of the virtualization, right? So all of these machines are ephemeral. They're spun up and waiting to allocate to you when you need them. And then they're destroyed and another one is built in its place once you're done, right? On top of that comes a number of Xcode stacks. So there's a 48-hour SLA that comes along with new versions of Xcode, right? This includes like beta versions. So as new versions come out, you don't have to pull a machine or a set of machines from your fleet, update them, and then have everybody test on it. You're able to just click a button and utilize the latest machine, making sure that it's ready for prime time when you're ready. And then lastly, all the information, all the tools on this stack being mobile specific are included here so that you can not have to spend that precious time downloading more libraries, dependencies, things like that. The majority of those tools already come pre-installed on the machine. And there may be a few that you have to download as needed, but it drastically reduces the time to actually get to building, which is why you would use a service like this. Likewise, and I'll slide over here really quick. So likewise, for automation to happen, you need the ability to script out your steps. What are the things that I need to do to build this application, right? And so this starts with git clone, right? I'm getting the source code on the computer. Maybe I'm managing some cache, running my unit tests, right? Setting up my dependencies. And then for iOS apps, it's going to be your Xcode, archive, and export to actually build that application. All of these steps come out of the box with Bitrise with a library of additional steps. I think there's around 400 to date to do everything you would need, from cloning Git to running your tests, even sending like a Slack or Teams message at the end. Right. If there's any questions there, happy to dive in at the end on all of the different steps that are available. Right. And let's slide back over into this this next section. So Bitrise is able to provide the infrastructure to actually build on with a nice editor. Oh, and I forgot to mention, this whole editor is backed by YAML. So if you're a DevOps pro or like to be in the YAML, you can also customize it there, right? So Bitrise offers you multiple of those things to handle that piece. Now, as we get into improving build automation, what does this look like, right? We automate it, and then we're looking at those next steps. So builds start to take longer, right? Because as the app grows over time, more dependencies, test coverage, things like that. Also, the team grows, so there's more throughput. And in today's economic climate, there's a lot of doing more with less. How can we get more throughput without hiring more developers, right? We still need to ship the same number of features, and our consumers are still expecting the same thing out of the apps, but we don't have the same budget to hire with reckless abandon the number of developers that we used to, right? So how can we do that? In comes in some additional topics that we'll talk about in our kind of walk, run, fly stages with build automation, parallelization, dependency caching, and some advanced build systems, right? Ultimately encompassing all of those inside of Bitrise. So the first step is parallelization with the walk approach, right? So if you've automated your build and it runs serially from top to bottom, how can we bifurcate some of those build tasks so that they run in parallel, thus reducing the wall clock time of your build, right? So we'll get into what parallelization is, which is here, right? Just parallel jobs run on concurrently on multiple workers, right? That can communicate with each other, so you can pass dependencies and things like that back and forth. It'll help you organize a little bit better. And obviously the biggest benefit is reducing the wall clock time of that build. So this is solved by setting up a pipeline. And essentially what you're doing is saying, we want to do a step, which is git clone, right? And maybe there's multiple steps that make up a workflow. So I get clone, I install CocoaPods, and I run the Xcode, archive, and export. Afterwards, once it's built, I want to run tests. And we have quite a few tests because the app is extensive And that tends to take a long time, right? So I get the binary that we built, I run my 100 tests, and then I publish results. In a pipeline, when we're parallelizing these out, I can say, let's build a stage of our app. And then after the app is built, I can split this test stage out into multiple different test runs. So instead of running, 200 tests serially, I can run 100 tests in one workflow and 100 in another simultaneously. Or even better, maybe I want to run 10 tests across 20 different runners and reduce the testing time from 30 minutes to an hour down to 5 minutes. This is what parallelization allows for you, right? And this is something already built into Bitrise. So I'll slide over here, and this example does a little bit more of running your linting as an example, and then I want to shard out my UI tests and my unit tests, and then if that worked, I'll build my IPA and deploy it. Right, so I've got a number of options there pre-built. The advantage here also comes about when a test fails or a stage fails, right? In some instances, you may have a flaky test, and this is characterized by I maybe have to run the same job 1 to 3 times, and then it will pass, right? Now, ideally, you would identify those and fix them, but it's hard to say that when you're in the middle of building and it happens, and you just want to know, did your build work? So Bitrise has a feature that allows you to rebuild the unsuccessful workflows without having to run through everything, thus reducing the time of a rebuild. All right, so now we talked about why we want to parallelize, right? Faster feedback on PRs, the ability to parallelize the task or test sharding, right? This makes it also easier to debug. So I could go into just the section of the test or the build component that failed without having to look at the whole log, right? Obviously, we mentioned rerunning those flaky tests obviously is faster and thus cheaper. And then it also helps you set up for subsequent flows or applications throughout the organization. You can reuse that template to standardize. Now, with parallelization, specifically in Bitrise, but pretty much across the board, by parallelizing, the usage cost doesn't change, right? You're running things concurrently, but the machine build time didn't change any, right? So you essentially took an hour build and broke it down into 6 10-minute blocks. It still took 60 minutes of machine time to build, but you accomplished it in 10 minutes of wall clock time. This is a simple example. I had a customer recently that had this exact scenario happen. So they were building a React Native app serially and had some automated tests in there, but no pipelines. Their build took 59 to 63 minutes. We switched them over to pipelines, running their builds in parallel, and sharded out some tests. And the build took 12 minutes, which is like an 80-ish % reduction in build time, saving those devs the rework from the context switching. One of those developers mentioned that the build took so long that because we're at home, he would go run some errands. Maybe that's I need to run to the store to go pick up something for dinner, or I need to go run some additional errands, right? And that was a big loss in productivity, and meant that he was making up that work later and later into the evening instead of getting to enjoy his time. So some nice advantages from speeding that up to 12 minutes. All right. So the next component is dependency cache. So we've automated our pipeline, or sorry, we've automated our build. We've added pipelines for parallelization. What's next? The next thing that I would add to your build is caching dependencies, right? This is a simple win. And just really quick, if we talk about what a cache is software that helps you store something temporarily in like a computing environment, right? So it's faster, but it's also more expensive memory. And so you don't want to store everything there. You just want to store relevant bits. And it's usually things that are frequently accessed. So something that's infrequently done probably doesn't make sense to cache. Things that are frequently accessed, like dependencies, are helpful to cache. And I like to use a story here as like a phone number to give you an example. So I grew up in an era where I needed to memorize everybody's phone number that I cared to talk to, right? And so if I needed a phone number, I'd have to think back, what's their number? Maybe I know the position on the keypad, and I would dial the number out. And instead, today, I'm able to save a favorite. I don't have to know their number, and I just click a button and it calls them, right? So much faster. Maybe I save my wife as a favorite. I don't have to remember her number, although although I know it, and I'm able to a frequently accessed person. I can call them and have that conversation. Right. So that's a short of what caching is. And as we get into what key value or dependency cache is, right, is the ability to store something with a key to differentiate it from others, right, so that you can find it easily later. This kind of relates to the favorite, right? I have somebody's name with maybe their picture on it, and I can quickly access it, that same contact every time because I recognize the picture. Same concept. We talked about this. Anything what gets cached is anything that is used frequently and doesn't change much, right? So I'm just doing some task avoidance there. This is really helpful for build tools, dependencies, some configuration. What's the impact of this, right? Why do you want to do this? So as we talked about, I kind of mapped out an example application. This would be like a React Native application going from, right, we clone code, maybe we install NPM packages. We're going to run some Android unit tests, build the app, run the tests, and build, and then also build the Android app is here, run the test. Then once that's successful, we're going to go and install dependencies for iOS, run iOS unit test, build iOS, right? Maybe run some end-to-end tests as well. And then I'm going to deploy to Google and to Apple. And that whole process, beginning to end, takes 60 minutes, which is an insane drag on waiting as a developer, right? Then we talked about in pipelines, we can parallelize this a little bit. Maybe we're going to get some benefit. We're still doing all the same steps, but because we parallelize this, it's faster. Now, adding key value or dependency cache, I'm no longer having to download over the network and in some cases build or compile dependencies. I can access those and then go to the next thing, right? This helps speed up even more. And this does impact not only your wall clock time, but also your machine time, right? So it's saving you even machine build time by utilizing it. Now, this is something here, I'll show you live in the product here. But in Bitrise, we have pre-built cache steps for really any dependency that you would have, whether you're an Android project using Gradle, to an iOS project using the many different SPM, CocoaPods, Carthage. Maybe you're using NPM for React Native or the Dart cache for a Dart cross-platform, right? A lot of different options there, as well as the ability with a generic cache step to cache virtually anything that you want. Maybe this is a derived data folder to speed up tests on subsequent builds, right? So we talked through the bulk of the easy wins, right? This is automating your build, parallelizing that build, adding in some cache elements as well. What's next, right? Why push further? This next piece is traditionally for larger organizations. So Xcode as a whole, not really designed for large teams. Usually once you have more than a dozen or two developers, you should start looking at an alternate build system, some other way of building, and usually it's through the command line, right? Also, as your developers and your lines of code grows, the build and test time grows, right? And organizations are looking to optimize. I started working with a large enterprise customer. This was a couple years ago, and their local build times were around 60 to 70 minutes. Now, there was a lot that went into their linting process, and as well as pulling fresh dependency sources from hundreds of developers, right, on this project. And that was a really big headache. Developers would go to click their code and run it locally and walk away because it took so long, right? So how do we optimize this? There's a few common tools in the industry that I would start to look at, and we'll go through some of these in detail, right? XC Remote Cache, this is probably the simplest to adopt, and it was developed by Spotify. It's open source. It's a plugin for Xcode, reuses some target artifacts from CI. It's still used by some. It definitely helps you get some wins, but Spotify isn't using it anymore. They switched to Bazel, which is at the bottom. And so the maintenance of it is fully open source. I would say it's not super well maintained. So it's not something I would just pull out of the box. You might need some expertise to help keep it running in your environment. Twist is another great open source tool. This is iOS only, well, just like XC Remote Cache, right? Another CLI tool, great support. It works great for Xcode at scale and simple to integrate. The performance is a nice step up from Xcode build, but I haven't seen. I think I see on average 40-ish% build time improvements over what you're doing now. So it's great. It works. But it's not the best. Gradle, obviously, this is a build tool for Android. Comes out of the box with Android Studio, and it was bundled with Android Studio. There's definitely some improvements you can make on Gradle. Gradle has an enterprise build cache. Bitrise also has a build cache very similar, right? So you have some options there as it relates to Gradle. Buck is another build system developed by Facebook. It is an advanced build system, so you can build Android and iOS with it. It's not very extensible, which was one of the challenges. and it's currently undergoing a heavy rewrite. So I would expect this to come back really powerful, but hasn't had the same adoption curve that Bazel has, which is the next one I'm seeing. Right. So Bazel developed internal project known as Blaze at Google. It's an advanced build system. You can build any app with this, right? iOS, Android, web, backend. Most of my large organizations that I work with are using Bazel across the entire organization to build applications, right? And this is what Google designed it to be able to do. It's very extensible, heavily used, and maintained by big tech companies. And I see this, if you have the size and the need for it, to be a good fit. Now, before we get too deep into what some of these are, I want to talk about how it works, why it works, right? So in a traditional sense, when you are building an app, a build is made up of one or more projects, right? And a project is made up of one or more tasks. And a task is that atomic piece of work inside of a build that can have multiple inputs, right? So as a guiding principle, we want to avoid rebuilding the tasks that have already been built, providing the input hasn't changed. So this is known as build without the bytes. So in order to do that, right, and I'll build this out, right? In the case of but all my inputs not changing, we know that the subsequent built artifact or task is not going to change. And so I don't need to rebuild that. Likewise, if an input did change, I know that piece needs to be rebuilt, and we go through that work. Now, on a simple stage, maybe it doesn't make that much difference. As you build this out, it can have bigger impacts, right? So in this case, and this is only a handful of tasks, I can save the building of 50, 60% of my build tasks, thus reducing the time it takes to build. Now, there are some complexities in setting this up, but the advantage is huge. Organizations that I work with that take advantage of some of these alternate build systems are experiencing 90, 95% build time reduction over what they're currently doing. Now, remote cache, we talked a little bit earlier about your local developers taking advantage, your local developer build time in that example I gave, where it took a really long time to build locally. That was impacting local developers on their machine, right? So adding to that, to help with that, we're adding a remote cache. Remote cache is used by a team of developers and the CI system to share build outputs, basically getting us back to that stage where we don't have to build as many things if they haven't changed. Usually what I see is 90 to 95% of builds are incremental, which means that I'm not having to build the majority of the app with every code push. So what actually happens here? When CI runs, developer checks in code, and that triggers a build. Bitrise or whatever build system is checking what tasks need to be rerun based off the input change. We're going to download any unchanged outputs from that remote build cache. And then we're going to populate the cache from CI with fresh outputs to be used on the next run. Also, that same cache is utilized by developers to speed up their builds. So no longer do those local builds take a really long time because we're optimizing on what's actually happening. So as we get into this a little bit further, right? Why would somebody want to do it? Usually I'm seeing, again, 90, 95% plus faster build times. So this is taking your 60-minute build time and getting it into like the 5-minute range, right? Now, that includes tests, because an advantage of these build systems, as long as we're setting it up right, is enabling you um, to skip over tests that don't have anything to do with the module that changed, right? So if I'm testing, if I made a change to settings, then I don't need to test some core functionality, most likely, if I just made a change to some obscure part of the application. Now, this used to take a really long time to implement. Organizations were taking a year, multi-years to refactor and adopt these build platforms. With some of the recent advantages and maintenance that have gone on inside these projects, it's now only taking a handful of weeks. Had a large customer do a full code base refactor. Now there was a team of developers on it to make this happen, but only took a month of time to refactor. Big thanks to the open source community and the things that are out there, right? The other advantage to this is you want consistency and reliability out of your builds, and this would be a top way to get it, especially at scale. All right, so how can Bitrise help in this area? Now, we're hosting the remote cache in the same data center as your CI and at the edge so that your developers can take full advantage of it, right? So this means faster builds, not just for your CI, but also for your local developers. As a benchmark, our Gradle remote cache that Bitrise is hosting is 95% faster than a clean build. The build speeds are insane across the board. Whether you're using this through Bitrise or through Gradle, the build speeds are the same, are crazy. And so those are definitely some options I would look into. Obviously, we mentioned the CDN at the edge is positively impacting the local developer builds. And then lastly, it's fully managed, right? So you don't need to be a top tech, FANG company to take advantage of these build systems. This is something that Bitrise is building into all of our products, similar into the workflow editor, so that it's simply a step that you add, right? I have an example here that I'll slide over and show. Actually here, right? So for this Android application, I am adding this activate remote Gradle cache build, right? I have a few options here to set it up, and the results are astounding, right? So for a build that normally takes 10 minutes, and this is a side-by-side comparison. So if I have no cache, my build maybe takes 10 minutes. If I add in some dependency cache, maybe that takes a couple minutes off my build, and now I'm at 8 minutes, right? However, when I add in an advanced build system and take advantage of that remote cache, my build is cut in half even further, right? This is 3 to 4 minutes of build time. Now, as you notice, when I have a cache miss, my build time is going to jump back up to about the same time as my dependency cache component, right? So if you have a cache miss, that happens. That's why it's important to populate this cache from CI so that you minimize those cache misses. All right, so let's see, we walked through some of this. And then lastly, tests and build steps for Bazel and Twist, right, as some examples. So going through and as we're wrapping up, the main purpose of this is to say, keep pushing further. hopefully this was helpful in allowing you to see how do we get from where we are today. Maybe that's in your crawling, or maybe you're standing still because you're still building manually, to crawling. How can we improve on that even more to start walking, running, and then at the right scale, get to fly, right? So hopefully these were some helpful tips and tricks of how you can do it on your own, or if you need help, Bitrise is here to help, and we are happy to set up a call and talk through this in your scenario. So with the remaining 10 minutes, Cody, happy to go through any live Q&A.
Awesome. So, Nick, I also just launched a poll to ask our audience whether they feel they're in the walking, crawling, running, or flying stage. So, everyone, there are a couple of other polls that are open for you. If you click that polls tab, you'll see there are 5 of them that are launched. If you haven't responded to them, go ahead and do so. We'd love to hear your feedback here. So, Nick, we did receive a couple questions, and to anyone in our audience, if you haven't sent one in yet, feel free to do so. We're going to tackle as many as we can over the next few minutes. So, Nick, do you have a CI/CD solution that includes embedded devices and bare metal servers running on-prem?
Yeah, that's a great question. So the first part that I'll mention, the embedded devices, Bitrise having the traditional setup is bare metal with virtualized environments. Um, there are no real devices plugged up to those machines, right? So you can run tests on simulators and emulators on that host. There's also a number of third-party organizations that build test your apps on real devices. These are organizations like Sauce Labs, Perfecto Mobile, Browser Stack. I think Amazon and Firebase also have similar services. So Bitrise integrates with all of those. We do have a partnership with Firebase Test Labs to run your tests on real devices. However, Firebase is limited to XCUI and Espresso tests. So if you have those type of tests for native applications, you can leverage our partnership to run tests on FTL for free, or you can leverage a third-party solution to run on actual physical devices. Now, for bare metal servers, we're actually playing around with this idea. It's not currently something that's out yet for running tests because you're looking for performance out of that bare metal server, which is the idea. And for everybody else, just to catch you up, usually when you're running on a virtualized environment, you take a slight performance hit, right? And so maybe that's 5 to 10% slower on average to run on a virtualized machine versus a bare metal machine. And so how can we maximize that, especially when we're talking about tests, right? So Bitrise has built from the ground up the virtualization component. So we're not using like third-party off-the-shelf virtualization. So we're taking advantage of some industry-leading components. This would be like GPU pass-through or pair virtualization, right? So taking advantage of some of these pieces, especially on Apple Silicon, has drastically reduced the network hit, or sorry, the virtualization hit that you take on that. So it becomes less of an issue. That said, if you have the need to run on a bare metal server, say in AWS, that is something that we offer.
Awesome. Thank you, Nick. That was pretty in-depth. Our next question reads, do you have some helpful guidance on setting up an advanced remote cache build system?
Yes, that is another great question. And I think that I have a link in here. No, let me find the link. And Actually, I can't find it right now. Cody, if I can send out like at the end, happy to send out a link to get more information there, or if you go to bitrise.io/contact and you can ask about that, and we'll follow up and provide you that information.
Awesome. Well, it looks like we are at a lull in our questions, but we do have about 5 minutes left. I'm going to go ahead and read out some gift card winners, and then we'll start closing things down. So the 4 winners of our $25 Amazon gift card drawing are George S., Diraj V., Allison M., and Bob R. So to those 4, congratulations. Keep an eye on your inbox to claim that gift card, but if you don't happen to see it in about the next 48 hours, check your spam folder just in case it gets filtered out. I'll also remind everyone that this session was recorded. You'll be receiving the recording via email shortly after we conclude the live session today. And you can also find it living on the DevOps website at devops.com/webinars. All right, Nick, we are at the top of the hour. So I did want to return the floor to you one more time. If you've got anything you think our audience absolutely needs to pull away from today, any parting words?
Yeah. Thank you, everyone, for joining. I appreciate the opportunity to talk to you a little bit about your journey in DevOps. If there's anything we can help, again, bitrise.io/contact. Happy to have further conversation.
All right. Well, Nick, thank you so much for joining me today. It was a pleasure getting to know you before we went live today.
Thanks, you too.
So I'd like to thank Bitrise for their sponsorship today. We could not have had today's program without the support of Bitrise. And to our audience, thank you so much for joining us today. We appreciate your time and we want to hear your feedback. So as soon as we close out, there will be a survey that pops up on your screen. Let us know your thoughts, maybe about today's program or what you'd like to see on a future program. Regardless, we do hope to see everyone at an upcoming Techstrong learning experience. Have a great rest of your day. And Nick, thank you once again.
Thanks, everyone.